Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on the bench I have a Sony F40. I don't know if it looks familiar to you or not, but I had a F60 on the bench here a while ago, and did a full service on that, and it turned out to be a real good performer. And this one here doesn't look any different. It's a nice little unit. It's got the same kind of look to it, same buttons, layout. It has a power meter up here. It goes from 0 to 50 watts. And this one has the pulse power supply as well. So it does have a switching power supply inside, and it doesn't have any transformers, so it's fairly light. It's not overly light, but it's light little unit. And what's it got at the bottom? It's got like a 3/4 removable bottom. And on the back, it's a nice little unit. It's got inputs for phono tuner auxiliary, and one tape loop, 2 sets of speakers, 3 courtesy outlets. What more do you need for a little amp? So this is from one of my clients, Rick, and Rick says that he used it, I guess Rick was a teacher? I'm not sure. He said that he used it when he was still teaching, and then when he retired he took it home with him, and he's been using it on and off. But it's a nice little unit. It's a nice compact size. It's got all the features you need. 2 sets of speakers, a little power meter, your tone controls, loudness, and then input selector. What more do you want? I don't know if there's anything wrong with it. I don't think there is. So maybe we should hook it up and see if we can get a signal through this thing. Alright, so the screws are out. Let's take a look at the lid. Looks good. A little bit of a dark stain there. What's that from? Something producing some heat. A little bit of heat production. And look at this thing. It's laid out quite similar to the other one, but it's more, looks like it's been modernized. This looks like our switch mode power supply is inside this stamped metal box here. And got a big bulk charge capacitor here. Big 820 microfarad at 200 volts. Pack quite a wall up. You want to make sure you check the voltage on this and discharge it before you start working on this thing, because you're going to have mains voltage coming in. It's going to be, well, actually it goes through the soft start system here, because we have a soft start system with the relay and the resistor, and then it goes through these bridge diode and then straight into the cap, so it's line powered. There's the amplifier itself. It's got like speaker relay, and it has the heat pipe assembly as well. This looks like it goes, heat pipe's a lot larger, and it goes both directions. So we got a bit of a heat zone right here. A little bit of dust. I'm going to take this outside and blow dust out, just because it's not that bad, but it's just while I can do it, I can do it. So let's do it. And our switching. The switches don't feel very good. Something wrong with that one, I think. Well, maybe it's working. Okay, looks good. Let me pull the bottom off. Okay, screws are out. Let's have a look. A little dusty. And yeah, oh, we got cracked solders on that one. That's that resistor. Here's our output devices. 2SA 1141s and 2SC 2681s. I don't remember ever seeing this complementary pair before. They're NEC devices, but it's in a Sony, so you never know. There's a few cracks here too on the soldering. I can see a few cracks here and there. This is the worst one though. Okay. This is the danger zone right here. It's all marked off, and this would be line voltage, mains, AC, and rectified DC. So don't touch there. There's the capacitor. We'll have to check for a charge on that before we continue. Alright, we're set up for a quick power test here. I got the 8 ohm load, 1000 hertz tone, scope set up, all the usual. Oh, this is a little bent up. Let's fix this up here. A wonky power cord plug. There. Okay, here we go. And you can see that, I hope. Let's turn it on. Ooh. It's making some weird noises. That stopped. That was odd. Okay. Do we have power? Yes, we do. Okay. Let's see what this thing can do for power. So there it goes right there. I think it's clipping right about there. 22.87 watts. That's 22.9, let's say. Well, I got a little too high. 22.6. That's going to be my final offer. That's actually doing really well. I didn't like that noise it made at the startup. It made a really weird noise. Let me try this again here. We got full power. And we're consuming 218 watts. You can calculate the efficiency if you're inclined. But yeah, it seems to be okay. Let's see, controls. Full power there. We got all our lights on in our power meter. Okay, bass seems working. Treble, a little bit scratchy on the right channel. Balance, scratchy. Loudness. Tape monitor. And then our function switch. A little dirty. So just typical switch cleaning, and the main volume pot is nice. Yeah, so I'm looking at this thing here, and some of these caps around these areas where there's some heat, I think I'm going to be changing some of these, but for the most part I think the caps can be left alone. A lot of these are okay, except for the ones that are exposed to the heat. Like there's 3 or 4 in this clump, and then there's a couple here. Phono stage, I don't think it's any problem. Let's test the phono stage while we're here. Okay, here's our phono. This is working fine. Let's try the, turn that down. Moving coil, moving magnet. So they need different signal lengths. Okay. Everything's working good except for the switches, and so we got clean switches, pots, cold solder joints everywhere. Replace a few caps. We still have to look in this box, this mystery box, and see what's going on and what magic's going on here. So let me pull that apart. Looks like it has a removable lid, 2-piece or 1-piece lid. Let's pull that apart. Alright, before you do any work, make sure this big black cap is discharged. The voltmeter, and I got 3.6 volts on there now, so we're safe. So remove 4 screws, one from each corner, and then the whole power supply assembly comes up. And you flip it over, and then you remove, what is it, another 10 screws all together, and then the lid should separate and provide you with access to everything inside. And then we have these EFI or RFI gaskets. We have to make sure we don't break those. And where's the other? Oh, this one fell. Alright, now we can do our inspection and recapping or whatever we need to do here. So I think what I'm going to do is I'm going to desolder these 4 wires just because it makes it easier to get away from the board. And then I can do cleaning, soldering, and all that stuff without any worry. Alright, so pull the cover off, check this over. Removed these 5 caps, tested them out of circuit, and they are all fine, so they go back in. These other 2 caps, they're film caps, 1 microfarad, tested fine as well. There's really nothing else to go wrong with this thing. And I checked all the solder joints, cleaned the board. One thing to note is these 3 screws here. This one in particular, this is your common center tap for the plus and minus rail voltages. And this one here is like a ground. That one was, oh, this one was loose. Just make sure these screws are tight. That one's loose too. So we had 3 loose screws. Same thing, like they have power coming in, power going out. You have positive and negative voltage, and then they rely on the ground, the chassis, to provide our 0 volts reference, or the common. And if this screw goes loose, then you lose that connection. So this is all ready to go back in. I'm going to reassemble it and put it back in the amplifier. Alright, so I pulled out both relays. This one's the soft start relay. I have a suspicion that this one is bad because when I first turned it on I heard arcing noise, and I think it was the relay. And this one's the speaker relay, speaker protect relay. So somebody has had these out and opened before because they pried, looks like they pried the lids off. There's scratch marks. They've never been desoldered. I don't think they were. But we're going to get into this right now. This is the this is the protect relay. And somebody's glued this together. Oh boy. Not very service friendly when you glue things back together like that. I don't know if I can pop this. Try and pop this cover off. There we go. I think that side's free. Let's try this side. Ooh, this side is really welded shut. Oh boy. Why they would glue those lids back on like that. Let me fight with this off camera. After a little cursing I got them out, but it wasn't like I had to butcher the end of the cap here. See this? But I'm not too happy about that. I don't know who glued them in before. I don't think the factory glues them in like that. That's insane. So anyways, here's your relay. It's a fairly simple design. These looks like these come out right out, and you can take them and clean them. That's the contact for the soft start. It's just the oxides on them. So I'm going to polish these up. Actually, I could check contact resistance to start, but I think I'll do that off camera. And I'll polish these up. These are the speaker contacts, and these are the soft start. So we'll get these 2 relays fixed up, and then we'll get them replaced or put back in. I probably do have relays. I'm going to check. Oh, we'll service these ones. These ones are serviceable. There's really nothing wrong with them that they can't be fixed. So we're going to do that. Alright, so let's get after cleaning this. I got this, it's just a polish. And I'm just going to use a small, I got a popsicle stick here, wrapped it in a paper towel. You know, one that doesn't rip easy. And let's just get a bit of this stuff. Doesn't take much, just enough to, oops. Yeah, it should be lots. Okay. I'm going to do these off, just pull them out. Don't forget their orientation or their location, and there's just see all the black that came off. Looking pretty good. Gonna need to do some this way. Yeah, that's good. Let's try this one. Let's put this one back, just so I don't forget where it goes. Let's pull this one out. See all that black? That's all oxidation. Okay, that's good. Okay, I'm going to clean these with alcohol, and then we'll put them back, and then we're done. Okay, relays are done. They're ready to go back in, but I'm going to wait. I'm going to take actually a bunch of these capacitors out. I'm going to remove some of these and test them. This is the main filter caps for the Amplifier 2200 at 63 volts. Didn't see any problems with them when I did the power test, but I'm going to check their value anyways. If they're down, I'm going to replace them, maybe upsize them, put them 3300s in. Or I don't think I have any 4700s that size. 63 volts though is not a common voltage, so I might just leave those alone if they're testing fine. These other ones, I'm going to pull some out and check any one that I suspect and replace them. And then we're pretty much done, other than I have to resolder the other side of the board because all the cracks. Okay, pretty much done with this. I'll explain what I did. Well, I reinstalled those 2 relays. I went through and I checked all these capacitors. These 4 in the center are bypass power supply caps for each. There's 2 for each channel, the power amplifier plus and minus. The rest of the caps went because they were pretty much garbage. They had low microfarads, high ESR, so a lot of them were just on that point of, you know, do I change it, do I not change it? So yeah, they came out, they got changed. There was a small amount here, there's, I don't know, maybe 10 or 15. Some of the other ones I checked, like these ones are good. That one's good, these were good. All the bigger ones, and then I replaced a few of the smaller ones within those. So that's where that stands. Did put a couple film caps in where they had like 1 microfarad electrolytic. I replaced those with film. I just do that regardless. It's a capacitor you'll never have to worry about again. And that's about it. Now it's time to do our testing. So what I want to do is I want to power this up and test our voltages. Now we should have about 170 volts on this cap. You probably, maybe you're asking, why 170 volts? Well, okay, so we have line voltage is 123, so let's do the math. So you go 123 volts minus 1.4 volts, and that's because we're going to drop 1.4 volts across these diodes, times 1.414 equals 171.2. So that's what we should read when we power this thing up. So let's get everything in frame here if I can. Here's our watt meter. Let me just lay this here. Lay this here so you can see it. And then we have a voltmeter here. DC volts. Okay. We're plugged in. It's powered up. Heard the first relay click there, and then I heard the second relay click. Okay, so what do we got here? 167.5. That's normal. Okay. 15 watts. We'll watch that. I didn't hear any arcing like I did the first time I powered this thing up. So now we should have... We got it live here, but be careful because we got high voltage here. I just want to check for our positive and negative rails. So here's our ground point, and here's one of them. I don't know which one it is. So that's our negative 40, 48.9. Here's our positive, 41. And there's two regulated supplies here. And these should be plus minus 25 volts. If you check on the emitter, 25.6, that's good. Check the other side. Where's the emitter? Emitter should be the first pin. Can't see very good. Just don't want to short anything out of this. Positive 25.5. So all our supplies are good. So now we can move on to the bias setting. Okay, bias. There's two posts here, and then your bias adjustment is just below it. So let's connect up our probes for the first channel. And the factory spec is 50 millivolts. And we've only got 10, so let's turn it up a little. I probably should let this, you know what I'll do, I'll adjust it and then I'll let it sit and okay, so I'll leave that for 15. Oops. Leave it there for now and I'll come back to it. And this side's already good. Okay. I'll give it 10 minutes or so of idle and then I'll come back and retweak that and then we'll call it good. Another thing you got to pay real close attention to is this screw here, right on the bottom corner. This is a ground screw, and this is actually a chassis. The chassis power is flowing through this. It's a return for the positive and negative supply rails. So this screw has to be intact and in tight. And there's another screw on the printed circuit board that's right here. That is another ground screw that's got a copper plate. That one has to be tight as well. So you got to check those two screws, make sure that they are tight. Yeah, this is why you always wait and recheck, because after about 10 minutes it climbed up to 19 and it's still climbing, it's still going up. And we're up at 22.5 watts here now. I'm just going to turn this one back down a little more. This is the one I didn't adjust. So let's just turn it down a little bit. And then we'll let it resettle and we'll check it one more time. That should be good. Let's do the other channel again. Oh, this one really went up. Oops, screwdriver got stuck. See, now you notice the numbers are going down? It's because it's cooling off. When it heats up, the numbers will rise. So just want to get this around 14 or so and just let it, yeah, right there is good. Even that's a little too low. This trim pot is very touchy. Okay, 14.2. You see our consumption went there, dropped down to 19 watts. So just let it sit for a while and idle some more. Alright, here we go. I'm going to do a power test. Got it wired in for 8 ohm load, 1000 hertz tone. So let's get this thing underway and see how it does. Plug it in. Where is my plug-in? Where's the cord? Here it is. And here we go. Alright, so we're starting off cold. This thing has 50 watts of channel. It's really surprising this little tiny little amplifier can do 50 watts of channel. It's quite impressive. I guess all the magic happens in this power supply box where it's supplying all the power it needs. Oh boy, what's going on here? We only got one channel. One channel dead. Balance. Bad relay. What's going on with that relay? I'm going to pull that relay out and do it again. Let's try that one more time. Shut it off. Turn it on. Yeah, we've got both channels. Okay, so the top trace left channel, that's the one I'm measuring. Let's see if we can get a read on this. Right about there, I think. We've got 22.35 volts RMS, and we're consuming 212 watts. Let this go for a while and see how this heat pipe handles all this power. So let it go for a while. So it's been on full power for about 5 minutes. This is starting to get nice and toasty. Not as bad as this though. This is the load and it's quite hot. This is actually, it's not too bad. You know, for a small size amplifier like this, pushing 50 watts a channel, I'm pretty impressed. So I'm just going to turn this down and we'll do some other tests here. Let's look at square wave. Alright, so there's the 1000 hertz tone. Looks very clean, very nice. We don't have any tone defeat, but here's a bass cut, bass boost, treble cut, treble boost, balance control. Still a little scratchy. Volume, of course, is working good. Let's go up in frequency. Three, 4, 5, 6, 7, 8 kilohertz. 9, 10. It's not too bad. This is 20 kilohertz. 20 kilohertz square wave. Now we're starting to see the effect of the speed of the transistors. Still pretty good. It's above average, I would say. There's no ringing, there's no weird stuff going on. It's doing pretty good. Alright, so I think it's doing really well. Okay, so time to finish this, wrap it up. Well, there it is, it's all done. It's back together again. This is the parts I put into it. Small amount of caps. These were all in the heat zone right in the power amplifier, and they all got pretty much cooked. They're all pretty tired. It didn't look like a high hours unit, but it must have some good time on it to cook the capacitors the way it did. So, but they're replaced. They're new. Really going to enjoy listening to this one. This is the smaller brother to the TFA60 that I did a video on. And when I finished that amplifier, it sounded really fantastic when I was listening to it. So I'm expecting the same for this. It's a nice little unit, nice and compact. If you want big sound, little space, this is the one for you, I think. But yeah, it's a nice unit. Treat to work on too. It was nice to work on a unit I didn't have to troubleshoot, not like that Marantz I just did with the nightmare problems. But this one's good. It behaved really well. So alright, take care, stay tuned, got lots of good stuff coming up. I don't want to spill the beans on it, but maybe I'll post a message on YouTube in the comment section, and we'll see if but anyways, that's it for this one, and take care, see you in the next one. Thanks for watching. Hi. Well, you thought we were done, but we're not. Okay, so I'll let you know what happened here. I put this on my listening desk and listened to it for a few days, and a couple of problems, 2 to be exact, cropped up. First one, the power switch is bad because I can hear it arcing sometimes when I power it up, and that goes on for 5, 10, 15, 20 seconds, and then it stops. So definitely going to adjust that. And we also have a channel that likes to cut out. We have left channel will go dead at random, and it has nothing to do with any of the switches or controls. So there's something internal to the circuitry that is making and breaking a connection and causing that channel to go. So we might have a cold solder I missed, or a defective component, or a bad chip or something. So we're going to get into this. So let's hook this up to speakers and a tone source, and we'll see if we can track down that intermittent audio. Alright, we're all wired in, ready to go, and plug this thing in for some power, and then we can get something checked out here. Okay, going live. Got 1000 hertz tone going in. I'll change it to 1440. Okay, so speakers B, here's our tone. So I'm going to go on the left side, and it's dead. I don't hear anything coming out the left, so let's poke around. Pretty sure it's not this relay. You have to watch out. All this here is high voltage, 170 volts DC, and that will mess you up, seriously mess you up quick. So don't touch anything around here. Just trying to see if I can kick that audio back on in that one channel. I think it's this side, I'm not sure. Could be something thermal too. It could be something up here. with the switches maybe. Now it's not coming back at all. Got my right channel, no left. It seemed like it was a thermal break, but then when I moved the unit around, it came back and would. So maybe when the board was flexing. I don't see anything going on here. Could be a failed transistor too. That's temperature sensitive. Not coming back. Let me spray some cold on it. Just going to focus some cold on these transistors here. Nothing. Let's try this side. Nothing. Completely dead channel. This one in the center here is your speaker protect. I wonder if it's the relay. I don't think it's the relay. Try shutting it off. Turn it back on. Oh, I can hear it. There, it's back. You hear it buzzing as it goes in and out. Okay, let me shut this off. I'm going to take the bottom off, have a look. Alright, I think I found the cause, but I don't know what's causing it. Now, you need to be careful here. This is high voltage again. So I'm scoping the output, and I scoped the output of the transistors, looks clean. Scoped around the relay, looks clean. I scoped the output of the channel, and it looks clean. But, look at this. Okay, here's the output of the speaker terminal, and here's the negative of the speaker terminal. That should be at flatline. It shouldn't have any signal on it. So we got a bad ground on the outputs. Here's the other channel. This is the positive on the other channel, the right channel. Here's the negative of the left channel, or sorry, right channel. Should be flatline. And here's the negative of the bad channel. So we definitely got a open or high resistance connection to ground through our speakers, which is causing it to cut out. And there's our clean signal coming out of the amplifier. So we got to figure out where that is losing it. Okay, so I was monitoring channel B. Happens on both channel A and B. So the negative wire for the left channel is this green wire here. If I follow this green wire back, it goes to the front panel right here, this connection. Can you see that? So if I manipulate that connection, it seems fine. Oh, we got something dicky on this board here. Could be the switch. Could be the switch. Could be a cracked solder too. So I'm not seeing anything here. Something in the speaker circuit for sure. So what I'm going to do is I'm going to take the front panel off again. We're going to have a good close look at this board here with this switch. Maybe the switch needs cleaning. But I don't think they would run the ground wires through the switch. I don't understand why they would do that. But we do have a bad ground here somewhere. And they bring all the grounds back here to this switch. So they're doing something. Okay, so I removed some screws. That goes back. This comes out. What's it hitting? Something. There we go. There we go. Now we can have a good look at this. What is the problem here? Okay, I don't see anything on this board that's looking bad, but let's reflow some of these joints anyway, and then we'll see. I think it might be the switch. They have these ground wires going through the switch. I don't know why they do that. So we probably have a bad connection on the switch here. Just going to reflow these. These ones as well. So what I'll do is I'll test it off camera again, and then we'll see if this is still acting up. If it is, we're going to yank the switch out and clean it. So let me get this back together so that it doesn't blow up, and then we'll give another test on this thing. So I'm pretty sure it's a switch, because that is the only... You hear the distortion in the left channel. Right channel's fine. The left channel is horrible. And I think what the switch does is it puts speakers A and B in series when you put them on A and B as both. Most speaker switches select A and then or B, and then it adds A and B together and parallels them. This one puts them in series. That's why they have the grounds coming back to the switch. So pretty sure the switch is kaput. We're going to disassemble it and we're going to clean all these contacts, and that should be the end of our noise problem. You can see it's just, I bet you if I check some of these I'll have a voltage on them. Let's check between this one and this one. Getting about 0.7 of a volt. And then we got 6.23 when it's open, but when I close it, about, yeah, it's jumping up and down. If I short these two out, our noise goes less. So that is definitely an indication. So let's pull that switch out and clean it. Alright, so this one has these funny tangs. Who made this switch? It's not Alps. I don't know where Sony gets their switches from. So, these are a little more complex because you have to make sure that they're properly aligned when you put them back together. So we have to remember either the fully clockwise or fully counterclockwise. Let's go fully counterclockwise. See, these ends here are kind of difficult. Well, not really, but I don't like opening them up because they're prone to damage. So you have to be careful with these and squeeze them together like that. And I need to get that one. Let's do these. That one's good. These are very easy to screw up and break, so that's why I don't like doing them too much. Let's get this under this side. Okay, and I can get do the other half. Okay, so we should be free. The plastic wants to come up. Okay, here we go. Alright, simple enough. Very black and oxidized inside, as you can see. I'll clean this up. So, that is our problem. These switches are not rated for the current that comes when you put the speaker outputs through. These are signal switches, not high current switches, so that's pretty much a failure on Sony's part. They just used the incorrect switch. This is really stuck on there. I might end up trying some polish on this one because it doesn't look like the contact cleaner is touching it very well. So the polish will take off any oxides. Yeah. Problem with using polish on these is you have to clean it after. So what I do is I put it in the ultrasonic after I'm done and get all that polish off, and then clean the contacts manually. See, but it's not coming off. It's not coming off. So we're going to use polish. Alright, got some polish here. Start with this. That's better. This is coming clean now. This polish is mildly abrasive. very mildly. Okay, just about done. Doesn't take much. You just gotta get it, you know, shiny again. Take the black off. Just try a little bit more. Okay, I think I'm done. You see that? That looks pretty good. That one looks pretty good. This one and the last one. All four sides. Okay, I'm going to dump this in the ultrasonic for about 15 minutes, clean all that gut cuff, and then we'll reassemble. Alright, here it is. It's fresh from the ultrasonic. Nice look at how it cleaned up nicely. Let's dry this off a little better. Might need to put a little heat on this. Maybe I'll put some heat on it just to drive off any residual water. This is only about 130 C. Everything is dry now. Okay. Let's put these back on. Alright, pretty sure they're in position. Let's treat them with deoxit. Just the tiniest, smallest amount. It'll distribute itself, don't worry. Okay. Oops. Leave it there, there. Okay. Now, this thing. Okay, so that is fully counterclockwise, clockwise. This. There. Now, I believe we're lined up. Let me check. Just put it beside and line up the notches. The notches, and then you can see if the spring contacts are in their little respective sockets. We'll just move these down a bit, because if they're not lined up and you put it together and you crush it together, they're going to end up bending. These are very fragile, so you just make sure they're lined up. Okay, well, that's not good. Wants to move. I think I have to move it one more, like that. Okay, I think we're there now. So let's try this. Okay. That's better. This is the hard part. This is the part you don't want to screw it up, because if you crush, like I said, if you crush those little copper contacts, there's no going back. Try and line them up so they I can go down on this somehow. I think I got it. All right. Now we have to spread these things. And I find if you take a screwdriver, go that way, go this way, that's good enough. You don't want to overextend these because they will snap off. And that's perfect. And then we put that together, and there's our switch. Okay. Let's reinstall that. Clean that up and then we'll test it. So there's a look at the contact resistance of this switch. I'm going to open it up, close it again. Let's open it up, close it. Yeah, I thought I checked this switch before and it didn't look that bad. Okay, but we're going to replace it anyway. So yeah, let's change the switch out. Alright, and my replacement is a brand new, I don't know which company makes these, but it is rated 5 amps, 250 volts. So we'll get this attached, and we'll also get a capacitor on here, 10 nanofarad safety cap, because there was no cap here. Maybe that's the reason why this switch had failed in the first place, but we'll get this put back together, and then we're going to have to glue on. Oh, I have to glue on the knob. I'm not sure. I don't want it falling off. Alright. Okay, let's. Okay, capacitor's in. Let's put this over top. That's good. Solder this one. Squeak this wire in here somehow and I can solder it. There we go. Okay. Now, let's fold this down out of the way. Okay, that's done. What I'll do is I'll hot glue this on, because I don't want it coming off. The other one was glued on and I had to pull on it pretty good, but we don't want to lose a knob switch. Okay. Alright, we are ready to do the final test. Let's turn it on. Everything's connected. There we go. Left channel. No, that's, yeah, left channel. See, when you go A plus B, it's silent because I have no speakers connected to A. And they're trying to wire them in series, so it's open circuit. That's why I got nothing on A plus B. And if I go B alone, it comes through. Right channel, still scratchy. Let's fix that right now. Can't really see here. That's better. Okay, so it is working now, and I got no problems with the switch. So that's it. We're done. I'll put this back together and continue listening to it. It does sound pretty good. I like this amplifier. It's a nice little amplifier. It's clean, small, doesn't use much power. You can hear it pretty much 20 watts at idle, and it's a good amp. You can turn it on, leave it on all day. It doesn't use a lot of power. But yeah, so this is going back to the owner after I do some more listening tests to make sure it's 100%. All right, thanks for watching. See you on the next one. Take care.